The broadcast is now starting. All attendees are in listen-only mode.
Hello, my name is Gino van Stralen, and today we are going to talk about external links to SCIA Engineer. This is the second webinar in a series of two, because at the first webinar we talked about the Excel link and the design forms tool that could be linked to SCIA Engineer. Because when you look at SCIA Engineer, you can identify different steps like modeling, then analysis. You have then your calculated results. Afterwards, we can do design and checks and then do reporting. Now, we have internal design and checks in SCIA Engineer, built-in design and checks, but you can also use your own or program your own design and checks using the design forms tool and or using Excel and linking an Excel sheet to SCIA Engineer. This was treated in the previous webinar, and today we are going to talk about the first part, the modeling part, because you can do modeling in SCIA Engineer interactively, but you can also do it via an external tool, your own written tool. And when you use those self-written tools, the way you do it is you will create an XML formatted text file. And with this XML formatted text file, you can either import this in SCIA Engineer, or you can also export those files from SCIA Engineer. Now, we can use this interactively, and during this webinar, I will show it in the interactive way. I will show some examples of these files. We will modify the files and see what happens in SCIA Engineer. But you can also use this as a batch command line tool using a file called esa.xml.exe. And this file is part of the setup of SCIA Engineer. So it is delivered together with SCIA Engineer. And with this tool, you can start SCIA Engineer without graphical user interface. So you will not see anything, but SCIA Engineer is running in the background. And you can read XML files, thus creating models, do modeling. And also with this file, you can do the analysis, do the results, so export results, you can do the design and checks, and you can do the reporting, all as a background process. Now, today we are going to show some examples, and but first, what is the trick? How does it work? In SCIA Engineer, we know a lot of different, what we call objects, like nodes, beams, loads, load cases, combinations, all those things. And all those objects, all those things can be exported and imported using a text file, an XML formatted text file. And when using this import, we can either create new objects, so create new nodes or beams, but we can also modify existing nodes, meaning we can change their X, Y, Z coordinates, for instance, and we can also delete objects using this XML file. And when using those files, we can do it interactively in SCIA Engineer. Today we will do it because I want to show you the principle, and you can also use it as a background process, and the last example will be like this. Now this XML file, you can make it manually using a text editor, or you can write your self-developed programs or tools. And the only requirement that you have is your development tool needs to be or needs to have the possibility to write a text file. That's the only requirement. So, and that is a very simple requirement. So you can do this using, for instance, the VBA in Excel, but also using Python scripting, JavaScripting, or a .NET application or whatever. So the only thing that you need is the possibility to write a file in text format. Now, this XML interface in SCIA Engineer exists already a very long time. It exists already since the beginning of SCIA Engineer. So there have been already a lot of customers or SCIA people who have been using this. So at SCIA, we have made a bunch of examples showing you how you can use this XML files and interface, and you can find these in the SCIA Garage at our website. So on our SCIA website, we have a resource center, and in the resource center you find the SCIA Garage. And in this garage, there are a lot of examples using this technology. And most of them are Excel workbooks. And we have some Excel workbooks for inputting combinations, and I will show this today. Nonlinear functions, strain load generators on beams, and so on. So there are a lot of examples, and they are free for download. So everybody can go to the website, can download the Excel file, and you go look into the Visual Basic macro, and you will see how it is done. Now, we also made a Koala tool. It's also made by one of the SCIA employees as a Grasshopper plugin for SCIA Engineer. Now, we are not the only ones who use this. We have also a lot of customers who have been using this technology to do certain things. So for instance, we have a customer who does rack buildings, and he will generate geometry loads, and he will also do optimizations, because with this XML tool, you can not only send information to SCIA Engineer, but you can also define the geometry loads, but you can also launch the calculation and read back the results. And when you read back the results into your own tool, you can start optimizing your geometry, your structure. Because one of the results, for instance, that you can export and then read back into your tool can be the unity check of the steel check. So the unity check values of the steel check. And if you read them back and you find that they are bigger than 1, then you know that you will have to optimize your profile sections. You will have to change them. And you can use it for simpler structures, but also for more complicated structures like roller coaster and other examples. And there are also external developers who have used this. For instance, ACOM, they've made the Panda tool for Grasshopper, for the Grasshopper to SCIA Engineer exchange. So that is also a tool that has been developed, and they distribute it, which can be used to link to SCIA Engineer. Now let's look at the examples. So I'm going to start with a simple example. And what I'm going to do is the following. Let's take SCIA Engineer and I put it on the screen. So this is SCIA Engineer, and it contains a small project. And what I'm going to show is, okay, I want here the coordinates of these nodes. I would like to move them. So currently the Z coordinate is at 4 meters, but I want to have them at 3 meters. Now you can do this inside SCIA Engineer by selecting those nodes and here changing the value, but this is not the purpose of this webinar, because now I want to use an external text file and I want to be able to control the XYZ positions of those nodes. So how is this done? So what I will do now is I will export, or I can export via this tool's XML IO document function in the menu. I can export here the table with all the nodes and their coordinates. So here in this environment, I now just took the table of the nodes, but in generally, you can here also put the table of members with the member definitions, the loads, the load cases, all those things that are available here. You can put them into this document, and then you can export these data as in XML formatted text file. And we do it using this button. So I can export this, and then I can export it to this file. Let's put a B there like this. Okay. Now when I go look there in that okay, here. So I'm going to look into this folder, and you see here that this file has been exported. This is the file that has been exported, and you can look at that file. So I will open it, and I will open it in a text editor. Here. And this is how this file will look like. In this case, I have added some spaces to make it more clear. So here you see the export of all those nodes, the table of the nodes, in this XML formatted text file. At the top, you see some headers with some strange strings here, but these are constants, so this is always the same, and it just describes, listen, we are now having a table with structural nodes, with nodes. And then you have actually a kind of table which says, okay, this is object ID 1, the name is N1, node N1, and the coordinates, the X coordinate is 0, the Y coordinate is 0, Z coordinate is 0, and so on. So you do it for all coordinates, let's say. So that's what is exported. And if I want to modify my structure, what I will do is, and I've prepared that, I've made a copy of this file, and now I've changed the coordinates 4 to 3. So for the 4 nodes that I have selected before, I now just said, okay, let's just change those coordinates, and I saved that file again. So this is my XML0102 file. And there I've changed the 4s into 3s. And what I'm going to do now is return to SCIA Engineer, and now I can just read this file. So what I'm going to do now is say File, update my project, and use an XML file, and use all data that you have found. I'm going to use this one now. This is the modified file. Open this one. And what you can see is that the coordinates have been changed, but using this external file. And we can see here that it has the value 3, and the Z coordinates are value 3. So what we did here is used an external file for modifying, in this case, modifying existing objects, as existing nodes. The other possibility that you have is you can also create new things. So currently in our XML file, we have 36 nodes defined, and when I change the coordinates of a node that is existing in my project, so an existing node, I just modify the coordinates when I give it other values. But when I add a line here, and I add line object with ID 37 or something, or more, and I give it a name and coordinates, then a new node will be created in the project. And the same thing goes for beams or for plates or all the other stuff, load cases and so on. If you define something in your XML file that is not yet present in your project, it will be created as a new object. And if you define something existing, so it is already existing in your project, then the existing object will be modified accordingly. So this is the first example. I will return now to my presentation. So what I did is, okay, I've selected the table of the nodes. It was visible here, and then I exported it into a text file, into the XML file, and it gave me this kind of file. And afterwards, we did the manual modification. So I copied the file, I changed some values for the correct nodes, of course, and then I have imported it back into the structure, and you've seen that the structure changed. Now, when you make your own tools, you will automate this. So your own tool will write those files in this format, and here you see the perfect example of how it has to be done. So when you define a table and you write this line with the name and the X, Y, Z coordinates, that's the way how you can define a node using your own tools, your own program. You write the file with this information. Okay. This was the first example, and now we will go to the next example. And the next example is input of combinations in using a VBA script in Excel. So how are we going to use this? in SCIA, and we have a SCIA Engineer project with only load cases and no combinations yet. And I want to be able to define the combinations, but now in Excel. I want to do it there. So what I'm going to do is I'm going to export my load cases to an XML file. I do an export and I read this file into Excel. And then I can define the combinations in Excel, and then I export the combinations back to XML and then import this into SCIA Engineer. So let's start SCIA Engineer again, and I will show you the example. So this is the project file with only load cases. So in this case, I didn't draw any geometry. I just have defined some load cases, and these are the load cases. And there are no combinations yet defined in this project. So this is empty, the list of combinations. So what are we going to do? We are going to say, okay, I want to export my load cases. So in this case, I've created a table with load cases using the same trick. I say new, and I search for the load cases. So for the load cases, and I add it, and this will show me this table, and then I can export this. So I can say, okay, load cases, I can export it to an XML file in this case. But now, instead of editing this XML file manually, I created here an Excel file with a Visual Basic macro. And with this Visual Basic macro, I can say, okay, import this XML file with the load cases. So in this case, I will just copy the path, which makes it easier, like this. And then I can import the LCSS. This is the file that I've created. I can import the load cases. And when I open this, you see my script, my macro will put the load cases, load case 1, 2, 3, 4, 5, 6. You will put it here. And now here I can now define my combinations. And here I can put the coefficients for each of the combinations. Now, I've prepared this because I do not want to be typing here 10 minutes. So I just prepared this, and I will copy this, and then I will paste it as a text, as a value. And this is how it should look like. So you have a combination ID, a number. You have a name for your combination and a description. Then you have the combination type. And when you look into the instructions in this Excel file, you will see that these are the types that are available. So you can define envelope, combinations, linears, ENULS, accidental, seismic, and so on. And also nonlinear combinations are possible. So this is this type. And then here you can just define your coefficients in a table. Yeah. So for each load case, each own coefficient. And when this is done, you can say, okay, export my combination. And now I create a new XML file with those combinations in it. So I will name it combis, and I export the information that I have here into a text file, and in this XML formatted text file that describes a combination in SCIA Engineer. Now, when that is finished, I can go to SCIA Engineer, and I can say I update my project again, and I choose this file, combis. I open it, and now I can go look into the table of combinations, and you will see that these combinations are now inside SCIA Engineer. So the information that was in the Excel is now here in SCIA Engineer. And we use this XML file. We exported an XML file from the Excel and then read it back into SCIA Engineer. Now I'm going to open the Excel again. Here is the Excel because I just want to show you. So it is in this Visual Basic. So this is the script, the macro that is inside this Excel file, and that writes that information. So here you can see, listen, if I have a Eurocode information, in this case, read the cells with the coefficients and write that back to the XML file. That is what is happening here in this code. So that is how you write here your own tool, your own macro to create combinations in SCIA Engineer, for instance. So and when I go back to the presentation, we can see that, listen, we did this export of the load cases, then we inputted here this table, we've inputted the coefficients, and in this example, I had linear combinations, non-linear combinations that were empty before. We defined it in the Excel file, and then afterwards you can see that both tables are filled. So you have used then the XML interface to create combinations. Third example is using this ESA XML, because up till now I have always used an interactive way. So one way or the other, I created an XML file. And the first example, I did it with my text editor. I just modified some values, and then I read the XML file back into SCIA Engineer, and you saw immediately the effects. And in the second example, I used a Visual Basic script macro in Excel to create an XML file with the definitions of the combinations, and then I also read it back into SCIA Engineer. Now, with the tool ESA XML, which is installed when you install SCIA Engineer, it's one of the files that is installed. You can do all this, but run SCIA Engineer in the background. So without the graphical user interface. And we also have an example of that. So I'm going to open my text editor again. Here. So here the combination, this is how a combination looks like. Previous example. So this is how in XML a combination is defined. Now for the current example, so we see this and we see, okay, I'm going to use this ESA XML file, and now I have a file which is called test batch 1, and with those commands here, with these lines, what I'm doing is the following. I open this file, the test batch 1 file, in this first call, and I say do an eigenfrequency calculation, an eigenmode calculation on this file, and when the calculation is finished, then write the results to this file. So write the project with the results to that file. And this is stats batch 01 underscore 01. And in the next line, I will run SCIA Engineer again, and I will open this file, the stats batch 0101. I will open it. I will do a linear calculation. This is what this lin means. And then I will save it again to 0102. And this file will contain the eigenfrequency results and the linear results. And then I continue, I open this file, I run SCIA Engineer again, I do a stability calculation and I save it again, and so on. I do a nonlinear calculation, a nonlinear stability calculation, and so on. So each time I run SCIA Engineer, but now using the ESA XML tool. And with the ESA XML tool, you run SCIA Engineer, but without a graphical user interface. So when I go now here, I can start this file. So this is the file here. But before starting, I'm going to stop SCIA Engineer. So I'm going to stop it and close it. And once that is done, I have this command file, and this is going to run now. I double click it, and you see now a text dialog saying, listen, I have started SCIA Engineer, and I do an eigenmode calculation on this file, and the results will be written to that file. And now this has been finished, and he starts the second calculation, and now he's doing a linear calculation on this file, and he will save it with number 02 at the end, and so on. Now, okay, ESA XML is a very powerful tool, but for a webinar, it's not so interesting because you can't see anything. Everything now is happening in the background. So I'm going to let it run, but I'm going to put it on my other screen and we can continue with the presentation. Okay. So this was what happened here. So I used this ESA XML tool, and I've created other files. Now this is just one of the examples what you can do, because normally what you can do with ESA XML is when you build your own tool, you do two things. First, you create this XML file with the definitions of the nodes, of the beams, of the plates, and of the loads and load cases. That's what you're doing with your own tool. You create those XML files, and then you launch ESA XML and say, okay, import this XML file. And that's how you create then your project using ESA XML. You create your project in SCIA Engineer, but without using the interface, the interactive interface. And then you can say, do a linear calculation or do a non-linear calculation. And with ESA XML, you can also export the results and, if wanted, read the results back into your own tool and do optimizations. So when you build your own tool, you use actually the combinations of the XML files and this is an XML tool. Okay, this is how it is finishing. So it is finished here. Now, when we look at some customer examples, I've said in the beginning, we have this functionality already since a long time, this XML interface. So, and it can be used to create quite complicated structures. So you can generate structures with it. You can use a parametric modeling tool, and then export that information from your parametric modeling tool to XML, and then import it in SCIA Engineer. So, and here also when you use a Grasshopper, you have a Grasshopper component, and this Grasshopper component will read information from the parametric modeling tool, and it will then use, instead of a VBA script and like in Excel, they have this graphical programming functionality with blocks, and each block does its own thing. But what they do here is actually create just this XML file which contains all the information and which allows to build very complex and very organic shapes in this case. Another example is this. So it's a customer who builds this type of structures, and in the past what they did was all the things they were doing, like making drawings, analysis, optimization, design, all those things were separate things, and they have integrated everything here into one process. And they use ESA XML throughout that whole process. So they have their back office system where they define their structures. They do they make quotes with it. They do analysis, optimizations with it, and everything is fully automated and much quicker and with less errors than in the past. Okay, what is the conclusion of this webinar? So SCIA Engineer can be used as a standalone application, and then you have those steps that you will follow, and the user will go through each step and have a report at the end with results and an optimized structure. Now, the built-in design and checks can be linked to external tools like Excel and design forms, where you do your own check, your own code checking, and so on. That is what I saw in previous webinar. And what we've seen today is that the whole modeling part can also be done via an external tool. And the trick there is that we use an XML text file, XML formatted text file. Now, to bind everything together, all those steps together, you can use the ESA XML exe batch command line tool. Because with this tool, you can say, take the XML, send it to SCIA Engineer, run the analysis. That's what you can do with this tool. It will get, you will have the results, and these can be exported back and read back into the tool, and you can do optimizations. So this is what this webinar was about. I thank you for your attention. If you have questions, you can put them on the chat and I will try to answer them.